Here we're being asked to make a rectangular area with algebra tiles with at least 6 tiles and label the length, width, and area. So I'm going to just and you can do any random thing you like, but I'm going to do mine as an x squared. Maybe I'm going to put an x over here, another x over here. Okay, and I need x's because if I put ones along here, I can't make a rectangle. Okay, I can't make rectangles with those ones there. But I could put if I want to make another layer here, I can maybe put another layer of x's this way because horizontally the x edge matches up with x squared as well. And maybe I'm going to do maybe 3 like this way. And then what ends up happening in this space here is I have edge lengths of 1, 1, 1, 1, 1 horizontally, 1's vertically. So those areas are just going to be 1's tiles like this. And that's going to give me a rectangular area. I don't have any pieces sticking out here. I don't have like an extra one over here. I have all my edges match. My x's match an x edge. Okay, x's match an x edge. All my ones match a one's edge. Okay, so this is a rectangular area, and I can now label the length and width. So this length here is going to be x plus 3, and the width here looks like it is x and plus 2, and the area then, I'm just going to write this out here. So I've got, and I'm not exactly sure how I would multiply this out because I'm going to have to group that bracket as my length, and I'm going to have to group the other bracket as my width. But what I do know is my area. I'm not exactly sure how to distribute that, but I know my area is going to be 1x squared, 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, 6 ones, so plus 6. So this represents my area. And what I've actually ended up doing is getting kind of a complicated looking multiplication, but I know this is correct because I can see my edge length is x plus 3, x plus 2, and I can see clearly my area is x squared, 1x squared, 5 x's, and 6 ones. So that is a bit complicated with algebraic tiles, but we can just see what's happening here, because really, how would I multiply out this multiplication? I kind of need to know how this multiplication here, this addition here, and this addition here interact when we multiply the two together. And we can show this then by just using some numbers here. So 3 plus 2 along the width, and then I'm going to do 7 plus 3 along the width. And I know this answer has got to be 5 times 10. So this has to add up to 50. And I know that's going to be the case. What's happening here? So 3 times 7 is 21. So basically, I'm distributing this 3 onto that 7. Well, this 3 here also shares an edge length with this 3 width here. So it shares with that. So this is a common side length for both of these rectangles. So I need to multiply 3 times 3 to get the area there of 9. And this side length of 2, well, 2 times 7 is 14. That means that this side length is going to interact with the edge length of 7, but it also is going to have the same edge length here of 2 times 3. So I need to multiply 2 times 3. That's going to give me my 6. And if I add this all up, I'm going to get 30 plus, this is equal to 50 square units. And that's what I would get if I did 5 times 10. So how do this multiplication interact? Well, the box method makes it very easy to see what happens. But we can see that this length here interacts with both these widths. We see that this length here interacts with both of these widths as well, because this length has an edge length both here and here. Okay, so that's my first distribution. Oh, maybe I'll just show that in a different color. So that's going to be like that. It's these two edges. Okay, the 3 is shared here and here, and then the 2 is shared here and here. So it has to be distributed to the 7, the width of 7, and the width of 3. So then if it works with numbers, it should work with algebraic expressions. And it does. If I want to show my width of x plus 1, or my length of x plus 1, and my width of x plus 2, well, I could see that it's going to generate these 4 area pieces, which makes sense because these are 2 pieces along the length, 2 pieces along the width, generate 4 pieces of area. And when I multiply this out, really I just have to make sure that I multiply this length to that width, this length to that width. So I end up with x squared plus 2x. I have to multiply, let's choose a different color here, this length to that width. That gives me my x. And this length to that width. That gives me 2. And I have accounted for all the parts of my area, so I know this must be the correct answer to this multiplication. And I'm just going to combine my like terms here. And so x plus 1 times x plus 2 is the same as x squared. This gives me the area of x squared plus 3x plus 2. If I have a length of x plus 1 and a width of x plus 2, I get an area that looks like this. Now, it might be easier to see it as 4 individual parts. Okay, so we can just leave it like that if we want, but since there are like terms, we combine the like terms. 2x and x into 3x. So the answer to this product of x plus 2 times x plus 1 is going to be 1x squared. Oops, there should be an x squared here. Okay, just make note of that. That should be x squared. So there's 1x squared. There's 3x's of area plus 2 1's of area.